The mystery of the watermelon skin. Why is it red on the inside but striped on the outside? A microscope view that will make your hair stand on end. When you think about it, it's strange. The flesh is bright red, sweet, and full of juice. But why is the outer skin of a watermelon green, hard, and most strangely, striped like a soldier's uniform? We're going on a scientific journey unlike any you've ever been on before. We're going to play detective, dissecting the watermelon rind to a level beyond the naked eye. We'll use the eyes of a microscope. There are giant spots, magical clear layers, and strange patterns that have been hidden all this time. Are you ready? Segment 1. The red versus green color paradox. Why does the watermelon have a dual personality? Inside, it wears a bright red shirt. Outside, it wears a camouflage green suit. The green color on the skin, both light and deep dark green, is the work of a great artist named Chlorophyll. Well, chlorophyll is like a solar panel. It captures sunlight and converts it into energy for the growing fruit. As long as the fruit still needs energy to grow, chlorophyll continues to work in the skin. So, who is behind the red color inside? It turns out that Lycopene is only produced when the fruit is nearing its retirement, aka ripeness. Segment 2. The secret code of the camouflage pattern. Now, let's look at the green coat. Why not just plain? Why the stripes? Scientists have discovered a special gene called the CLSC gene, or stripe coloration gene, that distributes a large number of chloroplasts, resulting in a dark green. In the adjacent area, there are fewer chloroplasts, resulting in a light green. Why does this pattern exist? It's a brilliant survival tactic. In the wild, unripe, plain green fruit is highly visible to frugivores. The broken stripes create a distorted shadow cast on the fruit's surface. Predators like squirrels or wild boars find it difficult to distinguish between the fruit and the surrounding foliage. This is the art of camouflage. Segment 3. Why is it slippery and shiny? Have you ever washed a whole watermelon and the water turned into small, round droplets like those on a taro leaf? Why is the surface of the watermelon's skin so smooth and slippery? The answer lies in the cuticle layer. This layer is a layer of wax secreted directly by the skin of the fruit itself. The function of this wax layer is not just to make it slippery. It is a high-level defense. First, it is hydrophobic. It hates water. This way, water will not easily pool on the surface of the skin. If water pools, fungal spores and bacteria will easily multiply. So, by making the water roll off, the watermelon prevents itself from rotting prematurely. Second, this wax locks in moisture inside. Watermelon is 92% water. If there were no wax seal, in a matter of days under the hot sun, the watermelon would deflate like a deflated balloon. Segment 4. Journey into the world of microscopes. Look at those giant green spots. They're large, round, deep green objects lined up. They're called chloroplasts. These objects absorb incoming light. Their large, round shape is due to having to accommodate as many chlorophyll deposits as possible. They're the reason why the skin looks green. Next, peeling off the green color. We peeled all the cells containing the green chloroplasts using a thin knife. It turns out that after the green color disappeared, the watermelon skin didn't immediately disappear. What remained was an extraordinary membrane that was clear, transparent like plastic wrap. Why is it clear? Because the outermost layer of all plants, called the epidermal tissue, is naturally colorless. These outermost cells don't have chloroplasts. Their job isn't photosynthesis, but rather to act as windows. They allow sunlight to penetrate so that the chloroplasts in the lower layers can capture the light. So, the green color we see is actually light leaking through the clear window glass. Segment 5. The mystery of the round pattern on the glass. Remember that clear surface? It wasn't perfectly flat. It had a pattern. The pattern was tiny dots, or thin, shiny plates. What was that? That was the true form of the wax layer. It formed microscopic crystals. So, what have we learned today? We know that the green on the outside and the red on the inside are the result of two different pigments working together, each with its own schedule. We know that the stripes are genetic code for camouflage against predators. We know that the slippery feel is a waterproof and antibacterial coat. And at the atomic level, we realize that the rind we're trampling in the trash can is a microarchitectural masterpiece. With clear windows, a giant green energy factory, and a field of gleaming wax crystals. Now, the next time you buy a watermelon, touch the rind a little longer. Feel its coolness, its shine, and its firmness. Because beneath your fingertips lie the secrets of evolution and the incredibly complex intelligence of nature. So, that's a brief but concise journey into the watermelon rind. This kind of knowledge might not come up on an exam, but it at least makes us more amazed at the simple things around us. If you enjoy content that explores the science behind everyday objects like this, don't forget to hit the like button, because it's incredibly helpful, and subscribe if you haven't already. There are many other little mysteries waiting to be uncovered together. Questions for you in the comments after learning about the inside of a watermelon rind. Are you interested in trying candy or pickled watermelon rind? Or will you stick with just the red flesh? Let us know below. See you in the next curiosity-filled video. Stay thirsty for knowledge, like a watermelon thirsty for water. And stay curious so that you try to find out and get rid of your curiosity about what is around you. Finally, thank you very much for taking the time to watch this video until the end, and hopefully this video can satisfy your curiosity.